Hello, welcome to Machine Learning and Beginners Python and Machine Learning. My name is Tim Cummings. Sorry for the delay there. I had to do a last minute computer change. But we're back on track, and so let's get started. So this is a Python session. It's a live session so that you can ask questions as we go, and that's really where you get a lot of value out of the session, is by asking questions, so I can answer exactly where you're having troubles. And it's the first week of the month, so we try to cater for absolute beginners. If you can ask any question you like, you can ask any question any week, but the expectations are that you'll be you're an absolute beginner, and so don't feel out of place if you feel the question might be stupid or whatever. There's no such thing as a stupid question. So you can ask questions either on Slack in this Learning to Code channel, which is part of Beginners Python, and you'll see in the video description how to connect to that. You probably won't get on there in time tonight if you're not there already, but do it now and you'll at least be there for next time. You can also ask questions on the YouTube chat, so I will be watching that as well, so you should all have access to that. Now we're going to use oh, hang on, can you see anything yet? I'm not. That's the wrong one. Let's try this. Okay, now can you see stuff on your screen? Yes. Good, thanks for responding. Yes, I had to I was frantically plugging in monitors and stuff to this computer so that I get it to work, because the mic wasn't working on the old computer. Alright, so we're going to use Google Colab, and that means you don't need Python installed on your computer. And we're going to be looking at functions today. It's a very could be a very introductory topic. There's advanced things you can do with functions, but we won't be doing them. So if you click on the link to Colab, which you'll see below the video, this will open a copy of the notebook that I've created. Let's make it a bit bigger, and you'll be able to follow through as we go. So learning objectives, how to use interactive Python, and that's what this notebook is. It's a form of Python. It's just a normal Python, plus it's got some interactivity built into it, so that it's faster to learn when you're using it, because you can see immediately the results that you get. So it's going to give you a bit of an introduction to coding, and we're going to look at functions. Okay, now I've just double clicked on that, and so it's gone into edit mode. Alright, now the first thing I'd recommend to do is click on copy to drive, and that way it'll store a copy in your Google Drive. If you don't have a Google account, then you can't do that, but if you have, then you can get a copy of it. Now you can make changes to it. I'll just close the release notes, we don't need to see them, and we'll work through this. Now I'm not saving outputs. If you want to save your outputs as well, it doesn't really need to save outputs, because you can always run it again and it will regenerate the outputs. So right, so a notebook, it's a mixture of cells. Each cell can have text in it, so I've put a cell here with some text, so a big heading here, meetup number 217, Beginners Python Machine Learning, and I put some hyperlinks in there and a bulleted list. So this is just a text cell. It uses the markdown language for formatting, and it's got code cells. So if we keep scrolling down, you see these cells here that which are green and they've got the play button, then they're Python code. So you can press the play button to actually run that bit of code, and at any point you can go between the cells and insert a new code cell or a new text cell. So let's explain first what Python, what you need to run Python. Now, when I remember a few years ago when I was first getting into Python, and I could just see so many different sorts of Python. There was C Python or IPython or JPython or Cython and Anaconda, and I didn't know which one I should be installing. So the advantage tonight, you don't need to install anything because we're going to use Colab, and that's the one. I've got to stop double clicking. Alternatively, I like just getting the straight Python. So this is often called C Python because it's written in C, but it runs the Python language, and you get that from www.python.org. The latest version is 3.13.5. And that's if you want to run Python on your computer, then this is the one that you'd run. Now, alternatively, you can install Anaconda. So Anaconda have tried to package up some useful things in Python that people would use. So they include many third-party libraries. These days, like the third-party libraries install really easily whenever you need them. So you don't really need, I don't think you need Anaconda. But in saying that, we're going to use Google Colab, which has got an install very similar to Anaconda in it. So it's got a lot of third-party libraries already there. Now you could also install an integrated development environment, which is called an IDE. It makes it easier to write programs. I like PyCharm, the community edition. Well, actually, there's now just the one edition, and you can just upgrade it. You can pay for the Pro, or you can run it for free with slightly less features, and the free one's perfectly fine. Or a lot of people these days are doing Visual Studio Code, which is not specifically for Python, but it's actually a very good lightweight IDE and is quite popular. Okay, now this one here is running CPython with the interactivity additions, and so it's actually called IPython, and I'll point out where we're using an IPython addition or whether it's just normal CPython that we're using. You can often see these called Jupyter notebooks, and this is Colab. I've talked about cells. Look up the help menu, so you've got the help menu up here, and we can use question mark. Alright, so let's try to run a cell. Here's the first cell. It's just got comments in it, so this is code that won't actually do anything. It's really just there for you to read, and so each line starts with this hash symbol, and Colab has very nicely color coded it for us so that it's we can see that that it's comments. And so if I run it, nothing will happen, but it will connect. You see up in the top right hand corner it's saying connecting. That's because Colab's gone, oh, actually you want to do something, I better make a virtual server for you to run, and so it's done that. Now you can see if I don't hover above it, it's put a number 1 in the cell saying it's been run, and then the next one you run, I'll put 2 so you can see which order you ran your cells in. It didn't do anything, but what I want to do now is if we uncomment this question mark and run it again, it'll run an IPython specific thing, which is help, and you can see over here on the right it's brought up the help on how to use IPython, so feel free to read through that. So let's get into coding. We'll go down to this second cell here. Coding is all about writing commands for a computer to follow. So the computers can only do things that are relatively simple, but it can do a lot of them very quickly, and it does them in sequence, so that's we can get it to do quite powerful things. So for example, if you want to display something, we can use this print command, and we put inside the parentheses what we want to print. So we want to print what's 5 plus 3, and it will display 8. God, this is annoying. I'll get the and it displays the result 8. Now that's something that'll work in just your normal Python. Because we're in IPython, we don't even need to put the print command in there. We can just put an expression that we want to evaluate, and it will display the result. Oh God, this is painful. And so there's the result for 4 plus 5 is 9. So you should be able to run these same commands yourself in your own copy of Colab, and you can change them if you want. Maybe change this to a 7, and it says 4 plus 7. It now gives the result 11. Now if you put more than one command in a cell, they're executed sequentially, just one after the other. So if I put print 4 and then print 3 and run that, it'll print the number 4, and then we get a new line, and it'll print the number 3. Unfortunately, in IPython, only the last line will actually display without the print. So if you do want to print more than one result in a IPython cell, then you pretty much have to use the same constraints that someone using normal Python has, and actually put print for each thing that you want to display. So if I put 2 and then 1, it's going to go through those lines one at a time, and then the last one is going, well, the result of 1 is 1, so I'll display that result, but I won't display any of the intermediate results. Okay. All right. So now let's get into variables. So variables are just memory locations, memory that you can store data in, and once you put some data in, then you can use that data in other things. So for example, if I said x equals 3, that takes the number 3 and stores it in a memory location that we've called x. And then whenever I want to get that number out, if I can't remember what I've put in there, then I can just refer to it by x and do calculations on the x, and every time it sees x, it will use the number 3 and then calculate a result, and then I can take that result and put it in a new variable location, which I'll call y. So if I run that and I print, and I'm just going to use an f string here. This is a Python thing for how to display values of variables. I won't go into too much detail on that. I've done a whole presentation on f strings, but you can see it's basically just inside curly braces, inside a string, you say what variables you want, and it will display them for you. So here we got x equals 3, y equals 1. So if you say, you can see we stored 3 in x, and then we did this calculation. So we got 9 minus 12 plus 4, and that should come to 1. And that's got number 1 got stored in y. And we can calculate y for different values of x and put all the x and y values into lists. And so I'm just going to introduce a few things here in the structure of a little bit of Python code. So this is a way of creating a list. I've called it lst_x, and I've created another one here called lst_y. And I'm going to start with x equals 0. And now I want to run some code over and over again, and this is the code that I want to run over and over again. So this is what's called a code block, and I designate the code block just by the indentation, which is something that Python does that not many other languages, or I don't know any other languages that do that. So Python goes, this is all indented by 4 places, so I'm going to group it all together. And the first line here for I in range 41 means I'm going to run this the next bit of code 41 times, and each time the value I is going to be the next value in a sequence. So starting at 0, so we get 0, 1, 2, 3 all the way up to 40, so that's 41 times. I'm going to calculate a value for x, I'm going to calculate a value for y, I'm going to append the x value into my list of x's and the y into a list of y's. and if I is less than 10, I'm going to print out some debugging so we can check that it's working all right, and then I'm going to print out what the total lists are. So yeah, one of the design principles for Python was that even if you don't know the language, you can get a bit of an idea for what's going on just by reading it. And so let's see if it does what you expect. So for the first 10 values, it prints out x and y, so 0, 0.1, 0.2, 0.3, and y, 4, 3.61, 3.24. And it stored them all in a list, and you can see here's a long list, all the x's that are getting stored, and I can scroll right to see all these other values. All looks good. There's a few funny things happening here. So when x is 1.1, rather than getting 0.81 as an answer, I'm getting 0.809996. And that's just a thing you need to be aware of when you're doing floating point arithmetic. We can talk about that some other time. Okay, so I've got a list of x values and a list of y, and now I want to plot them into a scatter chart. So I'm going to use a third-party library that fortunately Colab has pre-installed for me. If you were just using Python from python.org, you would need to install Plotly yourself. But if we run it, that imports it, and then we run the next line which says draw a line chart with those x's and those y's, and there it draws it for us. So we've got our x values along the horizontal axis and the y values are plotted on the vertical axis, and it's plotted them into a nice chart. So I'm really building you up here to where would we use functions, because this is a plot of a function which is a quadratic function that we might be familiar with in mathematics. Okay, so it becomes cumbersome and error prone to type in this quadratic equation every time we want to store a value in. I'm going to get rid of this help. Every time we want to calculate y. So what we can do is we can store the equation into a function, and we use this Python word keyword here called def to define a function. We define our function, and then we give it a name. We can give it any name that we like. I mean, there are a couple of restrictions, but just put in a few letters there. As long as you haven't chosen a keyword, you should be right. And then some parentheses, and we put inside the parentheses our argument that we want to pass to the function, and then it tells inside the function what the function is going to give back. So if I define this function by running that cell, it doesn't do anything, but now the function's defined, I can call it. And the way I do that is I use the name of the function, and then inside parentheses I pass what value I want the argument to have. So if I want it to be 5, it's going to return 9. So it's gone 5 times 5, 25, minus 4 times 5, which is 20. So that's 25 minus 20 is 5, and then we add 4 and gives us 9. Right, now I'm going to give you a task here, and I've left an empty cell here where you can start typing in your code to do this. Now I want you to call the function using an argument of 2.5. So think how you'd call this function, and you can just type it into that cell. I'm going to do it now. If you're still thinking, you might want to pause the video, but here we go. So I'm going to call the function, so I put the name of the function followed by parentheses, which means I'm going to call it, and then inside the parentheses I put the value of the argument that I want, which is 2.5, and then I can just run that cell by clicking on the play, and it comes back with an answer of 0.25. Now I've put a solution here, which is just a little bit more comprehensive solution. I've stored the 2.5 into a variable. I've called the function using a variable as the argument, and put the result of that into another variable, and then I've printed out in a nicely formatted print statement what the result is. So solution 1, f of 2.5 equals 0.25. So let's have a look at some of the things that can happen with these functions. As you've seen, when we're storing variables, we can just store any variable type inside a variable name, and we can pass that to the function. So if we pass 3 in Python, that's just considered to be an integer, which is like a whole number. It doesn't have any fractional part. And so it's going to return a value, and the value will have a type as well. So I've put a complicated looking f string here that will tell me what the type of the x is, it'll tell me what the type of y is, and it'll tell me the result of calling the function with that value of x and what the answer is. And then I'm going to do the same, and this time rather than x equals 3, I'm going to say x equals 3 dot. And when Python sees a dot there, it goes, this must be a decimal point, so you must be using floating point numbers now rather than integers. So there could be a fractional part. I'm going to assume there might be. So I'm going to class that as a float, and then we'll see what the result is. So let's run this cell, and you can run it yourself, and you can see that the input was an integer, then the output is an integer, and f of 3 equals 1, and it just displays as an integer with no point and no fractional part. However, in the second case, when I gave it a floating point number, it rightly assumed that it's a float, which is a way of saying floating point number or real number. The result from calling the function is also a float in that case, and so if I display the input and output to the function, the default way of Python displaying floats is to put 0.0 so that it's clear that we're working with floating point numbers. And so f of 3.0 is 1.0, f of 3 is just 1. So that shows the flexibility of our functions. We can just write the function that would work with one data type, but we can then a function may work with other data types as well, and we don't need to do anything special to make that happen. Now you can see I'm having to do this complicated line here every time I want to print the results, and when you find yourself repeating a bit of code over and over again, that's actually a good time to say, why don't I put that in a function, because then I only have to type it once in defining the function, and then I can just call the function whenever I need it. And then if I need to update it for some reason later, I just update it in one place, and everywhere in my code that uses it will get the benefit of that update. So let's create a function to make printing the return value and type easier, and so you don't have to see all of this every time. You just see print the function result for my function called fun and my argument called x, and it will run this function. It doesn't know what the function is yet, but it will call it passing in the argument x and return a value y. So let's define that function. There, that was quick. It's done it, and now we can do the same thing we did before with our integer and our float, and then we get the same results. And this code's a little bit easier to read than the other code, which had the very complicated f strings in it. So let's have we've got a task here for you. All right, try calling the function with an argument of a different data type. So we're going to use a data type called a decimal data type, which is similar to a floating point, but it doesn't have rounding errors that we saw before with the very long number of decimal places for some numbers. So the reason you use floats are a lot faster than decimals, but if you want something that's very accurate, I mean, floats are quite accurate, but they're not exactly right in some cases. But in this case, and it's all to do with the conversions from base 10 to base 2, which is the computer runs in binary, but we look at the results in base 10. But if we use the decimal class, then we can, it will do it exactly, get exact answers in decimal, the base 10 format that we're used to using and running, but it will take longer to calculate them. But computers these days are so quick that that probably won't be a problem for you. So I have to import the library. Decimal is a standard library, so I can just import it. I don't have to install it. So that's imported. Now try calling the function with an argument of a different type. Okay, and we're going to create a value using this function here. That's how we initialize a decimal. It's a little bit more complicated, but if you want exact numbers, then you have to do it this way. So let's say d equals decimal.decimal 1.1, and I can go into why we've passed it in as a string. It's because the if we didn't have the quotes there, then it would pass it in. It would immediately calculate it as a floating point number, and then we've lost that precision because in binary it doesn't store exactly right, and then when we convert it to a decimal, it's already lost its precision. So we'll do that, and we want to print the result. Print function result. Our function will be f, and we're going to pass in argument d. Let's see. Okay. So it did it for us. It worked. Told us that our x value, which is what we stored in our decimal, is of type decimal, and the y value coming out is of type decimal as well. And the result is 0.81. So that worked. In the solution that I provided here, it does the same thing, but it compares using decimal to floating point to see how the two results differ. It also shows you a different way of importing from the standard library, which is a little bit more concise, and so people would often do this when they're using the decimal class. They'll say from decimal import just the decimal class, which is with a capital D, and then when they use it, they don't have to say decimal.decimal every time. They can just say the one decimal. So you can see the difference here. We've got from decimal import decimal, and up here we just did import decimal. So both of them are right. This way, the second way is just a bit more concise. So let's run it, and there we see the difference. We pass in a decimal, we get out a decimal, and we get an exact answer. We pass in a float, we get out a float, and when we display the result, it's pretty damn close, but not exactly right. So for scientific applications, floating point numbers are fine. If you're doing accounting applications, they don't like having problems in the cents, so you probably use the decimal class for that. Alright, rewrite our loop from before, which created a list of x and a list of y, but this time calling the function. This time calling the function. Okay, so let's grab our loop from before. So I'll copy that and paste it in here. And this bit here is the line we want to change. So rather than type in the quadratic equation, we can just call the function f, which has stored that quadratic equation to convert x into y. Okay, and that worked, gave us the same result before. Remember, here's your result with 1.1. Here's a result with 1.2, etc. These ones here all worked fine. Python does its best to alleviate the floating point errors, but yeah, there's only so much it can do. Okay, so that wasn't too hard. Let's have a look at the provided solution. Okay, so the solution managed to get it down to 2 lines plus 2 printing lines to display the results. So this is a thing called list comprehension, and it's if you're building a list, you can, because it's such a common thing to do, this sort of code where you initialize your list, then you have a loop, then you calculate the values, then you append the values into the list and go through the loop. Because that's such a common thing to do, there's a Python syntax for doing that all in one line. You say you create a list, or you create your variable, you say it's a list, so we put the square brackets around it. Inside the list we put our loop, which is for I is in the range 41, so that'll go from 0 to 40, and then we calculate a value from that, which is I divided by 10, and then we store the result in the list. And then the same for list of y, and this time we call the function f on I of 10. So I don't expect you to understand list comprehension as an absolute beginner, but I'm just making you aware it's there. So if you do come across some Python code and you go, what is going on here? This is what it is. It's just the above code simplified into a couple of lines to make it a lot more concise. And the result is the same. Now it did have to do the loop twice, but it's still very, very concise, which can be good. Okay, so we've been looking at a function now, which is the had a quadratic equation in it, but we've actually used some other functions as well. So one of them was print. So anything that's got a name and then parentheses is calling a function. And so in this case, the print is a function rather than a command, and we can call it and give it an argument of what we want printed. So we could print, so if I run that, it just prints a blank line because I didn't pass any arguments into it. If I pass an argument here, which is a string because it's got these double quotes around it, it could be single quotes, they work as well. Print hello, so it takes the string and it displays the result out in the output. So task 4, what other built-in functions have we used already? So go back through the code that we've done already and see if you can find some other functions that we've used. Now I'm just going to go straight down to the solution to save a bit of time. So range was a function. It was it's a built-in function, and it had the 2 parentheses, and then we passed an argument, and we just passed with a single argument, and so it would produce a sequence of numbers starting from 0 up to, but not including the final number. Type was another argument, another function that we've called. We can put a value into the type function, and it will come back and tell us what type that function is. So whether it's an integer or a floating point number or a string. Okay. We also called a function px.line, which was when we wanted to draw the Plotly chart. That one we called the arguments slightly differently. Rather than just putting the arguments in there, we actually named them. We said we want x to equal our list of x values and y to equal our list of y values. So they're called named arguments. So that's a different way of passing arguments in, and we'll have another look at that later. This one's not a built-in function. It comes from a third-party library. So it needed to be installed before you could use it. For us, it was fortunate that Google Colab installed it for us. Decimal, so we created a object of the decimal class by calling decimal with the parentheses like that. It's not really a function, it's a class, but as part of creating an instance, it did call a function in itself, so it does call a function. Okay, so decimal is not built in, which means we need to import it, but it is part of the standard library, so we don't need to install it. Just a subtle difference there. Right, and by convention, classes use title case, so you can see decimal started with a capital D, and all our other functions started with lowercase. It's just a convention. You can not follow you don't need to follow it, but it's better to follow it because then other programmers reading your code will actually understand what you're doing. So things like classes will have names like that in title case. So all the start of each word will have a capital letter and the lowercase for all the other letters in the word, while function names and variable names we use all in lowercase, and we separate the words with underscores. Okay, functions don't need to have arguments. So the functions we've shown so far, except for one example with print, we've always provided an argument. But let's create a function now with no arguments, and this one is going to show what the current time is. So if someone wants to say show time, then it will run print, and it'll go to the date time library, it'll run the now function, it'll then format that into a string, and the string will tell me the year, the month, the day, the hour, the minute, the second, and the microsecond. So let's run this. I have to import date time because it's not a built-in function, but once it's imported I can use it, and then I can call show time. And there we go. The current time is the year 2025, month 7, day 2, hour 8, minute 8, second 20. So this is obviously in universal time, and that must be what Google have their servers set to when we connect it to it. So functions can do things, which is the functions we've created, which they've displayed results, or they can return values. So we're going to, here's an example of a function, time zone regions, that's going to tell me all the different time zones that are available. It's just going to tell me the regions, not the actual time zones, and it's going to sort them alphabetically and return that as a sorted list. So that's my example of a function. Don't need to understand how it all works. We're just really understanding how we've created a function. And you can see all of this part here has been indented. That's what's in the function. Once we're no longer indented, then the definition of the function ends and we're just back to normal code. So that defines, the top bit defines the function. The second bit down here is going to call the function to get a list, and then we're going to print out the list of regions. So there's our list of regions: Africa, America, Antarctica, Arctic, Asia, Atlantic, Australia, etc. So here we've got a task for you: define a function which takes one argument, the region, and returns the time zones in that region. Okay. So let's start coding. Now the first thing we'll do is define the function. So we've got to give it a name. So we'll call it time zones, time zone for region. So you see I've named it all in lowercase with underscores between the words. Time zones, in that region. So it's going to be plural. So time zones in region. That'll be good. That'll be the name. Okay, and the argument we'll pass in will be, we'll call it region, AI has decided that's a good name for it too, so let's just accept that. And then it puts a colon at the end, which means we're about to start a code block, and when you start a code block you indent, and Google Colab has indented for us. In your Google Colab it might be indenting just 2 spaces. I think I've configured mine to do 4 because 4 is more traditionally what you do in Python. But 2 is actually a very saves a bit of space, so it possibly will become the way of the future. Alright, now AI is suggesting I put in what's called a document string. We'll talk about that later. I don't think I will do it. So what I want to do, I want to go through all the available time zones. I want to check the region, and then I want to see if the region equals the region I've passed in, and if it does, then I'm going to add the time zone to my list. So I'll borrow this looping code here. And that's indented too far, so I'll just select it all and do Shift Tab to bring it back. Alright, so for time zone in available time zones, and then this bit needs to be indented, so I'll select it and press Tab. If the slash, so some time zones have got a slash in them and others don't. So New Zealand, for example, it's just a region with no time zones, no individual time zones, so it doesn't have a slash. So it is itself a region, and in for other ones they will have a slash first, like Australia / Brisbane, Australia / Sydney. And we want to store the results in our region, so let's have our list of regions equals an empty list. That'll do. And if we'll put a conditional in here. Actually what we'll do is say time zone region equals the time zone up to but not including the slash, if it's there. Otherwise the time zone region will just be the time zone. Equals. Okay, so we've calculated the time zone region, and the AI is jumping ahead for us. So now we want to compare that time zone region to the region that got passed in as an argument, and if it equals it, then we're going to add that time zone to the list, and then we're going to return the list. Now the AI's got all that done for us, so let's just accept that. And that's the end of our defining the function. Now we want to test the function, so we'll call some code for that. So let's print the time zones in region Australia. Well, there you go. It's been looking ahead, I think. So we run that and we get Australia West, North, ACT, Canberra, Hobart, Curry. Lots of time zones in Australia. So let's run it again for New Zealand. And there's just the one. And you see it doesn't have any slashes in it. Alright, so here's a solution that are provided. And you notice how when we created our function time zones in region, we copied and pasted some code from the other function. And whenever you're copying and paste, you go, maybe there's a better way I should be of doing this, and that is create a function. So I'm going to create a function here called region for time zone, and that'll do that bit of code, which will check if the slash is in there. If it is, then it'll return up to, but not including the slash. Otherwise, it'll just return the whole thing. And then I can rewrite my my first function, which was time zone regions, that just calls region for time zone for every time zone in the available time zones. And I could also call time zones for region, and it will call that function region for time zone and compare if it equals to the region, and if it does, then it'll store it in a list. So I've done a fair bit of list comprehension here and set comprehension, and then sorting the list alphabetically. So let's try a few of these and see how it works with those different regions. So the first one is Australia, as we saw. The second one is New Zealand. Third one is ETC, which is a bit weird. The next one is UCT, which is just a standalone. And then the other one is the time zone regions, which make sure that still works, and it does. It's got all our time zone regions there. Now the other thing that we did when writing these functions is we put these text at the beginning that we delimited with triple double quotes, which and what that allows us to do is put we can document our function. It's called a doc string. So the first line after you define a function is a doc string, and it's common to put in a multi-line string there. And multi-line strings in Python you can write by using these triple double quotes, and it says what the function does and some examples, something about it. And by doing those doc strings, then later on someone can call help on your function, and it will print out that doc string. So here we've called help on region for time zone, and it's printed out the how to use the function because we put that all into our doc string. So that's a really good thing when you're writing functions. Add a doc string, so you come back to it later, you can see what it does, and someone else doesn't even need to read your code. They can just call help on your function, and they'll get some idea how to use the function and some of the constraints that it has maybe. While we're talking about time zones, just throw this warning here about being careful when using ETC time zones, because they often go opposite to what you possibly expect. So for example, Brisbane is 10 hours ahead of UTC, so when we print the current time, with the time zone it will print it as plus 10 hours. So that is how it describes the time zone, as plus 10 hours from UTC, and the time, as you can see here, is 10 hours ahead. But if you were to use the time zone ETC GMT plus 10, then it actually goes 10 hours before UTC. I think what it's saying is Greenwich Mean Time is 10 hours ahead of it, and in this case Greenwich Mean Time is 10 hours behind it, which is the same as Brisbane time. So that's one to be careful with. The other thing when you're using time zones, I'll just throw this in, you don't have to remember it, but we used, I'll go back here, we used the zone info standard library. That's a new standard library that's just come in Python 3.9, and it replaces some third-party libraries that you might see in old code, and probably in new code as well, that have used these libraries PyTZ and dateutil.tz. Going back to help, so we can call help on the built-in functions as well. So if I run help on print, and this is just the doc string that the person who wrote the print function put in there so that we can look at it, and it tells us things about, uses a bunch of arguments, unnamed arguments, which is the things that it will print, but then you can put in these named arguments afterwards, which you can say I want each thing that I'm printing to be separated by a space, which is the default value, or you can change that to something else. You can say at the end of my print, I want a new line, which is \n is the way of doing new line. Or you can say I don't want a new line, in which case it will, when you do a print, it doesn't drop to the next line. And the file is where you're printing out to, and it defaults to sys.standardout, which is what you see, and flash whether to forcibly flash the stream. So when you run it, will it take time to make sure everything's gone through before it moves on to the next instruction, or does it just let that where the it's going to just let it queue it up and may not come out immediately? All right. Yeah, so this is, now we're going to look at named arguments. So you saw print had both unnamed and named arguments, and this is how you write a function that has named arguments rather than just putting well, in fact, we've always had, all our functions so far have had named arguments that we've written, because we've put an argument in here which is the name of the argument. So someone can, if there's more than one argument, they can add the arguments in whatever order they like, as long as they name them. So for example, if I want to have a function that tells me how many seconds are in a combination of minutes and seconds, then obviously I want to be provided how many minutes and how many seconds, and then I'll calculate the total number of seconds by multiplying the minutes by 60 and then adding in the seconds. So let's this is my sample, and then I'm going to call it. So I can call it several ways. I can call it this way, which is just using unnamed arguments, so I just have to put the values in the order that they're defined there. Or I can call them by name, in which case I can put them in a different order. So I can put the seconds in first and then the minutes later. Or I can use a combination of named and unnamed. But if you're doing that, the unnamed ones have to come first, and so they have to be the early ones in the order of the arguments, and then I can do the named ones after that, and they can be in any order. But obviously they can't be before the ordered ones that you've just done, because they would then be doubling up a value for the same argument. So let's run that. Total seconds 32:15 is 19:35. Total seconds equals 15, minutes equals 32 should give the same number, which it does, 19:35, and then a combination also gives the same. So I want you to write a function that now takes hours as well as minutes and seconds. So let's have a go at that. So we're going to write our function. We'll call it the same name, so it'll just overwrite what we've currently got. Total seconds. We're going to give it 3 arguments. Hours, minutes, and seconds. We'll put the hours in first, because that's the way people would normally use it. And hours, minutes, seconds. Now the other thing that we did here, did we talk about it? If we put a value next to the argument, that's used as a default. So if someone doesn't provide a value, it will use that value by default. So that's possibly a good thing. We'll stick in default values here. You see it's giving me an error and I put a default on the first one but not the second one. So once you start providing defaults, you have to provide defaults on all of them. Okay, return hours times 3600 plus minutes times 60 plus seconds. Yeah, well, that'll do. Okay, there's our function. Now let's have a look at the solution. And the solution is pretty much the same, except it's put in some nice documentation for us. So if we run that, we can see the different ways of calling it. So we've got calling by order, So hours, minutes, seconds, calling by name. So this still works. We didn't provide hours, so it's defaulted to 0, and then seconds and minutes. I've got those values to give us 1935, and here we're doing a combination. So the order, the unnamed ones have to come first, and then the named ones second, and then we can do name, and we can call them in any order. Okay, define a function which converts temperature in Celsius to Fahrenheit. All right, and there's the function that we're going to use. So we're going to take a temperature in Celsius and multiply it by 1.8 and add 32. So let's create our function. We'll call it Fahrenheit, and AI has looked ahead and at the answer and seen that that's how to do it. So let's just, why don't we just call it C? See if we can work it out then. Return C, yep, it did work it out. Return C times 1.8 plus 32. Okay, I'll press tab. There's our function. So not very hard. Let's have a look at the solution. It does the same thing. It's used a more meaningful named argument, which is a good thing. Return Celsius times 1.8 plus 32. And then in a loop, it's tried different values of C, 0 degrees Celsius, 100 degrees Celsius, and minus 40. And it's going to work out what the Fahrenheit value for each of those is. So 0 degrees Celsius is 32 degrees Fahrenheit, 100 degrees Celsius is 212 degrees Fahrenheit, and minus 40 degrees C is my favorite, is equivalent to minus 40 degrees Fahrenheit. And if you're interested in how I got that nicely formatted, you can look at these here. I said I want 2 decimal places, 7 characters wide, and so it's just lined them all up nicely for me. Okay, so now we're going to get into a bit more advanced things. And the main reason I'm showing you this, not that I suggest you use it in the early days, but just if you come across code that uses it, then you'll know what's going on. So say we had our parameters were in a list. So we want to call the total seconds function, and we want to take the first parameter and put it in for the number of hours, the second parameter for the number of minutes, and the third parameter in for the number of seconds. So we could do that this way, because we refer to this one as params square bracket 0. This one's the second item is, we use the index 1 because it's 0 index, so that's index 0, index 1, and index 2, and we can then pass those parameters into our function, and it can calculate it. It's 3,723 seconds because that's 1 hour, so it's 36. 100 seconds plus 2 minutes, which is 120 seconds, plus 3 seconds, which is 3 seconds. But Python also gives us a way to automatically unpack a list or tuple of parameters, and it's by putting an asterisk in front of the name. And so the first time you see that, you go, what is going on here? But that's really just saying I want to unpack all the values out of my sequence that I've got and pass them into the arguments as they are, and it basically just does that. So let's run it and just see it does that, and yep, total seconds of star parameters equals 3,723. But this is, you can also, as well as unpacking unnamed arguments, you can unpack named arguments. So if you had them all stored in a dictionary like this, seconds 1, minutes 2, hours 3, and if we wanted to calculate total seconds from that, we could say seconds equals params seconds, hours equals params hours, minutes equals params minutes. So let's run that, make sure it works, and it gives us 10,921. We could also unpack using this double asterisk notation, and that will pretty much write it out as the line we've done above, and we get the same answer. And then just to make things more confusing, you can do it the other way if you put the asterisk inside the function name. And that one, what that does is it packs up all the arguments that have come in and stores them into these variables. So a single asterisk will pack up all the unnamed arguments, and a double asterisk will pack up all the named arguments. And of course, if you're using a combination of both, you always have to do the unnamed ones before the named ones. And so we're going to store these into two variables. One's called args, one's called kw args for keyword args, and then we're going to print them out. So let's just see how that works. So in args, we've just got 5, 6, and 2. They're the unnamed ones. And then our named args, we've got 10 and FIFTH, which is what the values are that were passed in. And that's really just so you understand that code when you see it. When someone defines a function with these asterisks and double asterisks in there, what are they doing? And that's what it is. They're giving the user free flexibility of providing arguments, and so and we saw it before. Even in the print function, there was a reason to use star as args as the unnamed arguments, because when you're printing something, you don't want to be naming everything that goes in. Okay, well, I hope you found that useful. That's the end of today. I didn't get any questions, but that's it. I don't think, have I got... we'll go up to Meetup and see if there's another session planned. No, I haven't planned the next one yet. Okay, I better get onto that. But Arun's planning to do one soon on machine learning, so that'll be good. And I hope to see you again in the future. Thank you.